Hey everyone, welcome to week 3. We have two assignments that we're going to focus on this week, assignment 4 and 5. So let's start with assignment 4, which is called Experiment, Conjecture, and Proof. So the idea for this assignment is to really focus on those three steps that we're going through when we're solving our math problems. And we're going to use an example that we've looked at before, the race to n, but then really focus on those three steps. Okay, so there's a little blurb about the three steps, and we're going to experiment with some race to n's. So the idea now is to, because we already are familiar with this problem, now we're looking at some race to different numbers, and then see if there's strategies or how they differ from one number to the next. So if you're still not sure of a strategy for race to n for any number, maybe let's look at that first, because you really want to have at least that element down before expanding into changing the n a lot. So for any number, let me share my whiteboard. Um, so while I do that, think about like a race to 9. And that's what I'm going to work on here. So if we have race to 9, how do you guarantee a winning strategy for this game? So remember, the idea is, let's say you're X, you want to have X on 9. Okay. So if you work backwards from there, um, notice that if you get 6, then no matter what O does, you'll be able to get 9, right? Because if they just take 7, then you'll take 8 and 9 and win. Or if they take 7 and 8, then you just take 9 and win. So you know as long as you get 6, you win, right? And then working backwards from there, then if you want to get 6, then you'll want to get 3, right? Because as long as you get 3, if they take 4, then you take 5 and 6. Or if they take 4 and 5, then you just take 6. Right? And then once you have 6, you know you can get to 9. Okay, so we know if we get 3, we win. Well, how are we going to get 3? Well, we want them to go first, right? Because if they go first, they're going to either take 1 or 1 and 2. Either way, if we do the opposite of what they do, meaning if they take 1, we take 2, right? If they take 2, then we take 1, right? Either way, we'll get to land on that number 3. So the strategy for race to 9 then would be go second, like offer them to go, feel free, go first, and then I'll just go second. And then you're going to do the opposite of what they do, basically, is the idea. If they take 1, you take 2. If they take 2, you take 1, right? So there is our strategy for race to 9. Two things: go second, and then do the opposite of the opponent. Okay. Now, this strategy is going to change if we change the number 9. And that's the idea for this exercise, is experiment with some different race to whatever, and then how does your strategy change depending on the number. Or another conjecture could be, what properties does 9 have for this exact same strategy, right? Or are there any other race to numbers that have this exact same strategy? And then all of those numbers, what do they have in common? That's the kind of conjecture we want to come up with. So let me go back to the handout now. So for this first experiment, play at least 3 games with some different ends. I gave a suggestion of doing 12, 13, and 14, but that's not what you have to do, whatever works for your experiment. And do more if you need to, but just as far as recording for the assignment, you only need to record 3 games with 3 different ends, okay? And that's it, and then you're looking at the strategies and comparing them of those 3 games. I would recommend doing it in consecutive order. That way you'll have some different strategies guaranteed, and then you can compare them, okay? Once you experiment with some different ends, next we're going to come up with a conjecture, right? So a conjecture is a statement which appears to be reasonable based on your experiments, but we're not sure about the truth of it yet. It hasn't been established, but we're pretty confident so far, okay? So what you want to do for this part is make two conjectures based on your experiments from question 1. All right, so just at least 2. If you want more, that's fine. And here's some questions that might help you, right? Is there something you can do to guarantee a victory for any value of n? Are there some n's that don't work, some that do? Does the value of n even matter? Things like that. So any kind of conjectures you came up with about the value of n, you can jot them down here, okay? And then the final thing you'll want to do for this assignment is choose one of those conjectures and just rewrite them right there. Okay, and then you're going to try to explain why it's true, or maybe it's not true, in which you can disprove that conjecture. So the proof is really the why. And so clearly explain why your conjecture holds true. Doesn't have to be a formal mathematical proof right now. It just needs to be a clear explanation. If it's not true, maybe you can come up with a counterexample of why it's not true. Okay. Okay, so that's the idea for that assignment, and that's the end. So it's not too long, but it's really focused on those 3 elements: experiment, conjecture, proof. Okay, the next assignment we're going to look at is it's called the handshake problem. And this one is all exploration. Just kind of have fun with it, really. The idea now is that, so this is totally different, right? We're changing gears completely, brand new problem. The idea is, okay, suppose you have a group of 4 students. How many total handshakes will they have? Okay, so everyone introduces themselves, everybody shakes hands. How many total handshakes took place? Okay, so some hints there. Remember, you don't shake hands with yourself. So for example, Alba, she's just shaking hands with 3 other people, Ben, Carlos, and Danielle. All right, so you want to try to figure out how many total handshakes there are, okay? And you'll do it for 4 students, for 5 students, for 6 students. Each time you want to draw a picture and then come up with the answer and a short explanation of how you figured out the answer. And then finally come up with a table. So if there are 2 people, how many handshakes, etc. Do it all the way through 10. And then are there any patterns in that table? And then you're at the end of that. Okay. If you need a little bit more help getting started with that, I'll show you how I would get started. Let's do a new share. Okay, so let's say we had a group of 13 people. I think that's 13 sitting around a table. How many, and they all shook hands with one another. Everyone shakes hands with everyone. How many total handshakes are there, right? So let's start with student number 1 here, say. They're going to go around and shake everyone's hand. So maybe you can draw something like this, right? Where each line represents a handshake. Okay. And then now student number 1 has shaken hands with everyone. And that was a total of 12 handshakes. Now student number 1 is all done. Now you can move to student 2. They're going to shake hands with everyone except they've already shaken hands. Shook hands, shaken, shook. They already shook hands with student number 1. So now they're going to go around and shake hands with everyone else. So it gets a little crazy with your picture, especially because I'm doing it with a large number of 13 here. Yours won't look so crazy with your 5, 6, or 4. Okay. And I think that was 11 handshakes. So I add that to the list. I had 12, right? And then I had 11. I can kind of keep track of how many I have and just keep on going until you've calculated the total number of handshakes. Right next, you would go to 3. They've already shook hands with 2 and 1, so they're going to go and shake with everyone else. All right. Okay, so have fun with that one. Hopefully, once you get to that table, you'll see some mathematical properties and patterns pop up that you can jot down. Okay, send questions my way if you have any this week. And I hope the class has gone well for you and enjoy your week. Talk to you later.